The next topic that we need to talk about is independence and a rule that relates to that called the multiplication rule. So the first thing we need to talk about is what it actually means for events to be independent. And not surprisingly, it means exactly what it sounds like. If two events are independent, then they do not depend on one another. The outcome of one event, in other words, is not going to influence the outcome of the other event in any way. So you do need to be cautious when using this multiplication rule that I'll show you in a minute, because it only applies when two events are in fact independent. Some events won't be independent. For instance, you can think of this in relation to the sampling with replacement or without replacement that I talked about in the last video. If you have a bag of marbles, let's say they are, I think we used red and blue last time, and you're trying to figure out the probability of selecting a red marble from the bag, then the events are independent, the probability that you're going to get on each draw, if you are replacing whatever marble you select each time, because the number of marbles aren't changing in the bag each draw, and the ratio of red marbles to blue marbles is not going to change if you are putting the marble back in the bag each time you select a marble. The events are not independent, draw after draw, if you do not replace the marble each time. And that's, of course, because what happens on the second draw is going to be dependent on what happens on the first draw. So that's really all there is to independent events. What happens in one event is not going to affect the outcome of any other event. So when you have that situation, you can use this multiplication rule that simply says that the probability of events A and B, which we can write as the probability of the intersection of events A and B, is simply the product of the two events independently. The probability of event A times the probability of event B. And remember, this only works if the two events A and B are independent. It will not work if they are dependent on each other. So let's take a look at an example. Let's say that event A is that we're going to draw a red card from a standard deck of 52 cards. And event B is we want to roll a 4 on a die. And we want to calculate the probability that both event A and event B occur. Now, first of all, like I just said, we have to confirm that these are in fact independent events. And you can probably see that they are. The card that we draw from the deck is not going to have any influence on the number that we roll on the die. So these are in fact independent events. And because they are independent, that means we can use the multiplication rule that says that the probability of A times the probability of B will give us the probability that both events occur. So let's go ahead and calculate this. If we want to draw a red card out of a standard deck of 52 cards, we know that half the cards are red, so that's going to be 26 red cards out of the 52 total cards. And then we know that the probability of event B, that we roll a 4 on a standard die, is 1 out of 6. And so to get the two probabilities, we simply have to multiply those two individual probabilities together. Of course, 26 over 52 is 1/2, and 1/6 can't be reduced. But now they're a little bit easier to work with. So the overall probability that both events occur is 1 in 12.